Vanakkam one and all, we will discuss problem number 19 of exercise 5.1. Here, show that the function defined by g of x equal to g of x is equal to x minus greatest integer function of x is discontinuous at all integral points. And here, greatest integer function, it represents greatest integer function. This is greatest integer less than or equal to x. So the function has been defined like this, and we have to show the function is discontinuous at all integral points. Before proving this, we will discuss about greatest integer function. If I say greatest integer function, okay, so I'll give you a few examples to understand this definition. Suppose if you are given a number 2.3. So for that we are applying this greatest integer box. So here in this box, according to the definition, the greatest integer less than or equal to x. So the integer less than this 2.3 means we have lot of infinite number of integers which are lesser than this, but they are stating greatest integer. So we have to consider the integer 2 for this. Even if we draw a number line 1, 2, 3 minus 1, okay, in the number line we have this 2.3 is in the interval 2 to 3. Now this 2.3 is integral it's a box value will be 2, because according to the definition greatest integer less than, so less than x, less than 2.3 will be 2. And suppose we are having an integer in the box means it will be 3 only. Suppose 3.1. So 3.1 means the 3.1 will be in the interval of 3 and 4. So according to the greatest integer function definition, 3.1's value will be 3. Suppose we have 2.9. So according to the definition, the integer greatest integer lesser than this 2.9 is 2. Okay. For 2.5, its value will be 2. So this is what greatest integer function. Even it is defined for negative integrals too. Suppose our value is minus 7.5. So the greatest integer less than this minus 7.5 will be minus 8. And minus 4.5. The greatest integer lesser than this will be minus 4. Sorry, minus 5. So this is what greatest integer function definition. Okay, we have to know this. Suppose the value of x is exactly an integer, no problem, we will write it. And for any integral value, for any point on the real line, we can find a neighborhood, left hand neighborhood and right hand neighborhood. So these values are differing, the limits are differing at the integral points. Okay, say for example I have 1. So this 1, I'm taking 1. The greatest integer function, I'm applying greatest integer function for this one. So in this case the value will be 1 since it is an integer. Suppose in the left hand neighborhood of 1, I will have numbers like 0.9999 or 0.999 like this. So again the greatest integer less than this number will be 0. Okay. Now I will consider the right hand neighborhood of this number. In the right hand neighborhood I will have right hand neighborhood of 1, I will have numbers like 1.2. So the integer, greatest integer lesser than this 1.2 will be 1. So we can generalize it. Let n belongs to an integer. So for the greatest integer function for this n will be n, as it is an integer. In the left hand neighborhood, n minus h means left hand neighborhood, we will have the value of the box as n minus 1. See, here just now I explained, when we take 1, we are getting the box value as 1. And when in the left hand neighborhood of 1, we are getting 0, which is nothing but 1 minus 1. And in a right hand neighborhood, we are getting 1, which is n. Yes. Now in the right hand neighborhood of n, we will get the value of the function as n. Now we will show the function is discontinuous at integral point. So we have chosen n, which is a integer. So we are proving this for any integral point. So let n be any integer from real line, and we will prove the function is discontinuous at all integral points. Now the functional value at n will be, if here I am considering n as integer, so n minus box n. According to the definition, I will have n minus, as it is an integer, its value will be n, so I will get 0. Now I will calculate limit of the function. Limit of g of x as x tends to n from left hand neighborhood. In the left hand neighborhood, okay, I will write n minus h, okay, minus and n minus h. Here I am applying box for the second number, and we are not having a box here. When x is equal to n minus h, as x tends to h, as x tends to n, h tends to 0. So limit h tends to 0 for this n minus h minus limit h tends to 0, we will get n minus h. Here we have greatest integer function box. So we will have n here minus, according to the definition, we have n minus 1. So we will get n minus n plus 1, which is 1. So the left hand limit of the function is 1. Now we will take right hand limit. Limit x tends to n, limit of g of x as x tends to n from right hand neighborhood. In the right hand neighborhood, we will have n plus h. So n plus h minus box n plus h. Now we will apply limit when x is equal to n plus h, as x tends to n, h tends to 0. So limit h tends to 0 for this expression. So limit n plus h as h tends to 0 minus limit h tends to 0 n box n plus h. Now this expression will be n and minus, here according to the definition we have to take n minus n, which is n minus n, which is 0. Now here the left hand limit is not equal to the right hand limit. So we can, hence we have proved for all integral points, at all integral points the function is discontinuous. With this we are done with the proof. Okay, to solve this we need to know the definition of greatest integer function, which helps us to check the or discuss the continuity of the function. Thank you.